Welcome to another edition of the dOrg Hot Seat. Today we have Dan, the head of engineering of Orchid Protocol, and we're gonna run through some questions that either the dOrg members or myself will throw to Dan. So Dan, let's get this party started.
Let's do it.
I first heard of Orchid Protocol in 2019, and it at a great party at DEF CON in Osaka. I think I was the last person to get out of that party. It was great. I have great memories about Orchid Protocol, and it used to be all about. We learned in that party. We learned everything about the centralized VPNs, and now it's almost 6 years later. What has changed? What is Orchid Protocol now? It's still a VPN.
Yeah, it has always been about building decentralized marketplaces for networked computing services. And in the beginning, we identified the bandwidth marketplace as the thing that'd be sort of the shortest runway to launch, and so we built the Orchid VPN as the first of several. We hope eventually many different marketplaces where people can trade decentralized service. So we've expanded to storage, and that is still in the design phase right now. You can follow it along. We post our meeting minutes and have a growing sort of white paper or maybe yellow paper in development. It gets continuously edited in our GitHub repo. And we've also dipped our toe in generative AI, and we've got an LLM chat app that is really at the demo phase right now, but I hope to make that something that could be participated in sort of more interesting ways as we go.
All right. So we have like these sort of marketplace to share resources, and we're on bandwidth, we're on storage, and we're on compute, but specialized on AI, right?
It's
Um,
it's a sort of a way to back our way into GPU compute, but yeah, you can draw the line through generalized compute as well.
okay. Okay, perfect. Okay. So here, like, how would so there's on any marketplace, right? There's like always this the supply side and there's the demand side.
Mhm.
So often what happens, especially with tokenized projects that try to incentivize people to share their resources, that you end up with a bunch of supply
Mm.
and not nearly enough demand uh, to actually make use of these incentives. At the same time, you do need to bootstrap this supply, because the worst that can happen is that your service doesn't work because there's not enough supply for it.
Right.
So how are you guys dealing with this problem? And so actually, before we get into that, maybe you can tell me if I got the actors right. Who are these actors, and what are their roles?
That's a classic problem in these decentralized marketplaces, that you over incentivize the supply side, and it's a ghost town. Nobody's using it, and so once the incentives dry up, the marketplace collapses. And we we do have some VPN partners that professional VPN services that we partnered with at launch to make sure that there would be something available. But we've really taken a firm stance of not over incentivizing supply. We don't want to follow that typical pattern. of of share, some kind of incentive or reward for running a server that then nobody ever uses. Uh, and uh, and so we are looking to more organically bootstrap these marketplaces. The goal is win people's attention and participation through either cheaper service. Obviously, a lot of times the decentralized services will be things that people are running, kind of in an amateur fashion, and so you're gonna have to accept that you might get lower quality service some of the time, but that could be compensated for by having a lower price. The expectation with bandwidth has always been that there's lots of excess capacity out there. People could sign up to provision some service to the network and undercut the professional VPNs on price. Or alternatively, the professionals could sell some of their excess supply if they're if they're underutilized at any given time. They can jump in and quickly sell off their excess capacity at whatever the current spot price is. Um, so. Uh, that's sort of our approach here is specifically not to pay people to sit around idle. We're expecting that people will jump in and sell into the existing demand, uh, you know, if the demand shows up.
Right on. Okay, so what are the products that one can use now, and sort of what is how would I use the Orchid protocol?
Yeah, today there's still one fully productized application that is the VPN. You can download the VPN client in the Google Play Store and Apple App Store, and you can also download builds from our GitHub repo. There's a Linux and Windows command line client, um, and we try to really live and die by the decentralized principles that anything that is not yet uh, uh, ready for fully permissionless, fully obstacle-free, fully uh, you know, no single point of failure, no individual actor in control, including, like I said before, no single actor funding usage, or sort of incentivizing participation that's not organic. We don't set it loose and call it a product. So the other thing that you can interact with today from Orchid is our generative AI demo. It's an LLM chat client. You can use our web app to talked to over 30 different models. Today, Orchid is running the nodes that are brokering access to these services. So we don't call it a product today because we're being a centralized provider of the service. But as we we get the legs under that product and actually make it ready for everyone to participate on both sides of the marketplace, then we'll promote that. I would hope to something that we stand behind as a full Orchid product.
I mean, that makes a lot of sense, right? Like, we we keep hearing that sort of like the bottleneck for AI products is where to build this capacity, where to build these data centers, where like how can you secure and ring fence enough GPUs for your product and not the others? And that's such a Web 2 mentality. That's like such a not efficient way. Um, if we could sort of tap into like a decentralized network of GPUs, which technically I'm sure it introduces a lot of latency, a lot of like its own issues as well. But economically, it just makes a lot more sense to basically have this network of distributed compute or GPUs, and then you can tap into it from wherever you want, basically. So let's get deep about, like, I'm actually super nerdy about this kind of things, and distributed AI. Like, how what are the main complexities? You say you're running yourself the servers now. Um, what's the path forward for those models run in a distributed fashion?
Yeah. So today, we're we're using as sort of our test case today, uh, a pretty simple model of brokering access to the sort of the major LLM services, the major inference services, from OpenAI, Anthropic, Mistral, DeepSeek, and both uh, in China hosted DeepSeek and other sources through OpenRouter. Largely, it started as a demo of how you could apply a fairly simple, a fairly thin shim in front of a centralized service, or well, in front of any kind of service, to convert a more heavyweight subscription style relationship to a pay-as-you-go nano-payment driven uh, uh, you know pay by the token access. And that model translates nicely to other sorts of services like RPC, to market price data, uh, and so that's something we're exploring. Not just for inference, but other places where you might have access um, to some data through an API that is currently inconvenient to access on a sort of pay per request basis. For inference specifically, I think looking beyond the sort of the major sort of first party services from OpenAI and Anthropic and such, I I think that fine tunes and RAG with proprietary knowledge bases is probably the most interesting thing from a decentralized perspective. There's always going to be one model that's the current leader in the field. It's going to be run by a centralized service, uh, and if what you care about is just the raw intelligence, the largest training corpus, you're probably gonna have to go that route. I think it's fun to apply our payment model to their service, but it's really just reselling a centralized service in the current state. Um, when you start to think about, well, how could a larger community of service providers get in on this and offer something compelling that's not just more hands touching the same data, or providing a somewhat less perhaps a somewhat lower quality but maybe lower price service. uh, I think you got to look at where do people have something unique that they can layer on top of something probably more of an off the shelf model. And so you know, if I've gone to all the effort of gathering case law from some particular facet of the legal system, or some large mostly offline or even just inconvenient to access pile of information, scientific papers or what have you, I've done the effort to actually pre-process all of it and deploy it for RAG. Then uh, that could be something that I could then sell as a service that nobody else is gonna have, or I'll have relatively few other people who can beat me on quality of service, or the better model or something that's um, serving that I'm serving. So uh, I think that's going to be the most interesting place for a decentralized marketplace for inference to go.
All right, so you'd have like this sort of um one entry point, and then you'd have like big foundational models that you can access through that entry point, but then like other people could inject themselves into this marketplace with specialized maybe proprietary data or specialized models that are more specific to this. So like what so we could be talking about this forever. Like what is that, or how is that different from like creating tools that call specific APIs for like proprietary models as well? And do they even want that? I would imagine yes to capture it, but never mind. Let's go back to Orchid.
Sure.
And I think so. Orchid started as a VPN because it's there's an overabundance of bandwidth, right? It wasn't the only project. There was Sentinel, there was Mysterium,
Hmm.
and now, lo and behold, there's Gnosis VPN coming up. Why why so many projects, and what is not solved on the VPN world that we need so many VPNs?
Hmm. We need so many VPNs. I think it's an attractive uh, uh, service to jump into because the privacy narrative I think resonates with us as as a
Web3,
demographic here that
privacy. Yeah.
yeah, if you're interested in decentralized systems, you probably tend to also take as axiomatic the importance of privacy. Uh, and it turns out it's actually a quite challenging market to penetrate. The big players are actually they're making all their money on selling subscriptions that nobody uses, and that model doesn't translate to a decentralized project very well. Subscriptions are harder with the tools underneath of us, to to set up, and it that goes against our one of our
Mm.
guiding principles, right? You use what you pay for what you use, and only and pay for everything that you consume. And so pay as you go as a model, does just looks so very, very different. The So I think that people jump into VPN thinking that there's a large demand out there for for privacy as a service, and then it turns out that a lot of times what you're doing is you're just changing who's actually handling your data, and potentially
Mm.
handing it to people who could be more motivated to abuse it. So um, yeah, I'm not
Do
convinced
you
that
worry about capture, about the protocol capture? For example, we know that most of the Tor exit nodes are, well, not maybe not most, but a substantial part of Tor exit nodes are controlled by actors that want to have active control over the traffic of the Tor network. Do you worry about this as well?
certainly it's a concern, right? If you create a product that is a little more difficult to use, or a little more complicated to set up and to understand, it may be, if you have a multi-hop VPN circuit in there that's going to be it'll increase your latency, and so it'll just feel less pleasant to use than a cheaper free VPN. Uh, and so the people who are going to take those trade-offs are going to be the people who most need the privacy. Well, now you have yourself a honeypot uh, for the bad actors, we might say, or at least the people who
Any
will be.
programmatic measures that would,
Yeah.
or maybe like user choices that the user of Orchid can take to try to minimize their exposure to capture?
Yeah, well, so certainly onion routed multi-hop circuits are the correct choice within Orchid, and part of how we've been backing our way into this the compute service is looking at ways to put more tools in the hands of the user against the attacker. You have to start thinking about things like correlation attacks based on timing of your traffic flows. And if you have you set up a 3-hop circuit, your entry node and your exit node could be held by the same person, and so now they just have to look at the timing of the packets that are going through, and they can de-anonymize the user. You end up having to do things like what we term bandwidth burning, where you send chaff packets through that fill the line and essentially create a steady flow with no timing information left in the circuit. So I I think that programmable behaviors in the circuit itself are going to be what's required
Mm.
to deliver a strong privacy guarantee, and so that's something that we're actively exploring right now.
The other thing that I wanted to talk about, and you mentioned it before, it goes embedded with the, the 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 philosophy that you have as pay as you go and stuff. Is uh, streaming probabilistic nanopayments. Can
Hmm.
you talk a little bit about this?
Yeah, well, so uh, your goal is to pay just for what you consume, and you want to do it at as fine-grained a level as possible. So we asked ourselves, well, what is the smallest payment you could possibly make? And when we launched on Ethereum, that was even still back in the ETH $250 days when gas was cheap. It was still a large a large overhead. You wouldn't want to pay for a small amount of service with individual Ethereum transactions. So we came up with the idea of probabilistic nanopayments, where instead of transmitting value on chain, actually exchanging the currency with every payment. What the sender the client sends to the provider is a chance of receiving a larger payment, but at a small probability that it will happen on any individual round. So we call them lottery tickets. The client is sending sort of like scratch off lottery tickets to the provider. I might have, if I want to pay 1 penny for any given interaction, I can send a lottery ticket with a payoff face value of $1, but a 1 in 100 chance of winning. And we can do that in a cryptographically provably fair way, so that both sides can treat the value of this lottery ticket as 1 cent, even though 99 times out of 100, it's not going to actually transmit any value on chain, or it won't result in an on-chain transmission of value. And so that way we can roll up many payments into effectively roll them up into one. You can roll them up 100 to 1. We can do it a million to 1. We can actually get down to very, very, very tiny payments. That's why we call them nano payments. And in the VPN, you're typically paying at about 250 kilobytes of data transmission per lottery ticket.
Wow, and that's fascinating. I can how like was basically Ethereum and the inability to constantly stream that forced you to come up with a system like that? Like
We
a
understood that.
technology, like a yeah.
Yeah, we understood that the payments were going to have to be smaller than could be supported by any realistic transaction cost, and
Right.
so you have to get off chain for these interactions, and
Hmm.
so the way we came up with it, or the way we solved that problem is don't actually exchange currency, exchange
Hmm.
value, notional value, and then only periodically actually
Hmm.
have it hit the chain.
That's fascinating. Um, you do have an L2 now, though. Is that right?
No, we
No.
tend to call it sort of a stochastic L2, but
Right.
it is simply just the off chain lottery ticket mechanism.
Gotcha. Okay, perfect. Yeah, yeah. I was about to ask about this because I was reading your website and your marketing materials. It seemed like I got a L2 slash L3 that got me a little bit confused. Um,
Oh, and well, sometimes we can talk about it as an L3 because we're deployed on L2s. Our so the lottery tickets are implemented through what we call our lottery contract. It's deployed as a trustless singleton through a universal deployer contract. So anybody can deploy our nanopayments, the heart of it, the lottery contract, to effectively any EVM compatible chain. So we've actually deployed it to 9 chains, but our account management DApp actually has a feature in it where if you want to use a different chain that is has the EVM compatibility to support it, you can point your MetaMask or whatever at whatever chain you want, and then you can pay the gas to deploy the lottery to that chain, and it'll deploy to the same address, and everyone can trust or trustlessly expect that it'll be the exact correct contract.
I had a lot of things, so I kind of like monopolize this because I wanted to touch on like several different topics, but let's let the team ask any questions if they want to. And in the meanwhile, I have one last in my pocket. Is if you right now had like unlimited resources, what is the one thing that you would build on Orchid?
Hmm. Resources. Well, I think that I you know I would just accelerate the things we're already focused on. Compute and storage uh, you know, are inching their way along, and I think as you get the full all 3 legs of the stool here, right? Storage and band and networking and compute. Things can get pretty interesting. I suppose that's maybe it's a bit of a cop out answer, but I'd like to just bring things to light a lot faster that we're already focused on.
Absolutely. That's excellent. Thank you very much, Dan, for coming here and responding to our questions, my questions in the end. Um, much appreciated. Where should we go to learn more about Orchid and what new thing should we be looking for when we follow you?
So Twitter or X is kind of our main outlet right now for day-to-day updates. Also, we organize everything into a mono repo, so you can find everything of interest at a deeper level there. And we haven't drawn a whole lot of attention to it, but mean to. The storage project has, like I said, sort of continuously updated information in the storage folder under the Orchid repo, and so um, I would certainly love to hear from the community ideas and use cases for our generative AI project. This is a little bit of a pet project of mine that turned into something a little more substantial. There's a few crash efforts for coming up with something fun to show off at ETH Denver a couple of years ago, and we realized, oh well, things have matured enough out there that there could be an interesting service. So everything that we build is free open source. So go grab our repo, take a look at things, look at the guy front end, guy back end, and tell me if what you'd like to see.
Fantastic. Well, thank you very much again. Will you be at December this year? Did you
I'm
mention
not
that?
going to make it this year, but there will be Orchid people there. I know at least Chloe, our mathematician, is going to be there. Probably a few other folks.
We will be searching for them. Thank you very much, Dan. Oh, we got one last question.
Hmm.
Vision for 2025.
Yeah. So this is I'll give you the frustrating answer on this. We do not publish a roadmap. We uh, we build in the open almost exclusively, so you can see everything that is currently underway, and you can watch it unfold. But we don't make promises looking into the future. Uh, so hashtag no roadmap. Just jump in and talk to us about what you see happening, what you'd like to see, and we're happy to talk about ideas and um, work together on things.
One more
When will the
question.
yellow or white paper be ready? Yeah, I ask the team this every week. It's I just saw a really promising batch of pseudocode for the heart of the storage project. It's the commitment scheme for how providers are able to self-audit and prove that they are continuing to store your data, and do this. Roll this all up with polynomial commitments, so it's extremely gas efficient to store your commitments on chain. Um, that had been one of the things that we believed should work, but until there's code, it's a wish and a dream and not a reality. And so that is, I don't think that has been added to the document you can find in the repo today, but it's I think going to get touched up and included there. So to more directly answer the question of when white paper, when yellow paper, it's now. It's just filling in. So it's it's probably the kind of thing that we'll look back on it and realize, oh, it was done a month ago. Not meaning 1 month from today, but some point in the future we'll figure out that we had already finished it. But it's a continuously evolving document, and um, so no specific deadline yet, no forecast, but check it out. Tell us where we're wrong. You know, tell us what's good, what's bad. We'll happily discuss.
All right, we'll check out the yellow paper. Thank you again, Dan. And I hope that we're gonna see that yellow paper finished very soon. See you not in November, but maybe see you next time somewhere else. Take care.
Sounds good. Thanks for having me.